Hello everybody. In this video we're going to get started with data analysis by first discussing data cleaning, which is an integral part of any kind of data analysis. Basically, data cleaning is all about making sure that your data is ready to go for any other kind of analysis. So this might involve something like looking at columns of our data in a data frame and saying, well, these column values aren't quite right. It might involve something like removing or renaming columns in a data frame. It might deal with how do we handle null values or not a number or missing data in a data frame. So we're going to be discussing all of those topics, but the first thing that we have to do is download the source code and unzip it somewhere. And so when you download the source code off the website and you unzip it, there will be some CSV files. So the main CSV file is flights.csv, and if you need a refresher on what kind of data is in there, you can look at something like the README, and if you open up the README, you get some information as to what all the columns are and what they mean, as well as some potential values that they might take, values and formats that they might take on, also units as well. And then if you're unfamiliar with some flight terms, you can always look through this terms.csv, and then there's just some other information, such as some codes about weekdays, some airport IDs, and airline IDs. So all this information is critical, so I suggest you take a quick look through some of this data, especially the README and the terms files, so that we're familiar with the columns. Okay, so after we have done that, and after you download the environment file and load that up, then we can get started with data cleaning. So we'll want to make sure that we have the right environment, and let's launch Spider. I already have an instance of Spider running here, and so I have a file open up in Spider. I'm just going to save this guy to the same data analysis folder that has all of my CSV files. So I'm just going to call this data cleaning.py. Excellent. So the first thing that we'll need to do is import pandas. So we'll do import pandas as PD, and the other thing that we'll have to do is actually import numpy as well, because we'll be using it for our data cleaning. And we have to load our flights dataset. So flights equals pd.read csv, flights.csv, and then we have to make sure that's indexed correctly, so we'll set that to false. And we can always check just by saying something like print flights. So this is just some code that will load our data and then print out some flight information. So let's run this guy. And after a couple seconds, it'll load up our data. So we have a lot of data here. And right, so there's some information here about year, month, air time, and then distance seems to be wrapped over a little bit. Sorry about that. All right, so we have information, and all the numbers seem to check out. Now you notice that it took a little bit of while. It took some time for us to load in that information. And actually, how this IPython console works is that we only have to load this in once. So from now on, what I'll do is comment this guy out, and just to remind you that this loads our flights data set. So I'm going to comment this guy out, and that's because anytime we run this file, all of the variables or things that we define are persistent in IPython. So in here I can just type in flights.dtypes and view all of the different data types for our columns, for example. And then I can do the same thing here because the flights variable has already been established. So this prevents us from having to run this file and then keep waiting over and over again for the data set to reload. We can just load it once. Alright, so it's interesting that I printed this out because this is what we're going to be looking at. So this flights.dtype just prints out all of the data types of our columns. So we can take a look. So year, month, day of week, or day of month, day of week are all int 64, which we expect them to be integers. FL date is flight date. And if you notice, this is actually an object, and an object is a string. But this isn't quite the appropriate data type for a date, right? You expect a date to be a date-time object, or in Python, we have these things called date-time objects. In Pandas also, there's a date-time object as well. So this isn't quite right. If we were trying to do any kind of time series analysis on this, it's a bit tricky to do it on strings, but if we had it as an actual date time, then we could do all kinds of things like add or subtract or multiply or add or subtract different kinds of date times, and everything would just work together because of pandas. So the first thing that we need to do is actually convert this column from a string to a date type. And actually we can view this column. I can just do flights fl date, and we can see this guy. So I print this out. The format seems to be year, month, and day, and it's denoted as an object, or in other words, a string. So we don't want this. We want this to be an actual date time object. And luckily, Pandas provides a way for us to convert between a string to an actual date time object, and it's actually smart enough to infer what the format is. So let's go ahead and do that. So what we want to do is, so this is part of data cleaning, right? Converting columns to their appropriate data types. So the first thing we'll have to do is convert the flights data. So we can do that just by saying flights fl date equals, and there's a pandas function I can call pd.toDateTime and just call that on the column flights fl date. And like I said, it's smart enough to infer what format it's in, or what you can actually do is provide it with a format, and then it will work like that. So we can run this guy, and you'll see there'll be an error undefined name, but that's fine because it's actually defined in our IPython console. This just prevents it from loading it 100 times. So we've run this. So let's see what the actual result is. So I can run flights.fldate again, and you'll see that content-wise it hasn't changed, but now we have the appropriate data type, date time. Excellent. All right. So that's exactly what we expect it to be. So now we can do any kind of arithmetic with the date time stuff, for example. So there's some other columns that we're going to look at actually, flights.dtypes. Okay, so some other columns that we can look at. Let me just make this a bit easier to see. Okay, so in particular there's canceled and diverted. So if you look through the README, you'll notice that canceled and diverted are actually just Boolean values. Canceled is set to 1 if this particular flight was canceled. Diverted is set to 1 if this particular flight was diverted. These don't really make sense for them to be float 64s. In reality, they should be Booleans. And that's something that we're going to convert. So let's convert these guys to Boolean values. So we'll do flights canceled equals flights, and this is where NumPy comes in actually. Flights canceled dot, and I can say as type, and then specify a NumPy type to convert to. So np.bool, and what that will do is take this column, convert it to a Boolean value, and then save it back into this column. So now we can run this guy, and now if I run flights.dtypes, you'll notice that canceled is now a bool. So what I'm going to leave as a challenge for you guys is to do the same thing for the diverted column. So there's a column called diverted, and you'll have to write the line of code that converts it to a Boolean type. And to give you a hint, it's going to look very similar to the line above, line 11. So we'll do that, and we'll be right back with the answer. Okay, so to convert diverted to a Boolean, we have to pretty much do the same thing. So we'll say flights canceled diverted equals flights diverted dot as type np.bool. And actually, before we run this guy, let's actually just see what it means for this to be a floating point value. So I can just, before I run this, I can just say flights diverted, and you'll see that really it's just 0 or 1. There's only 2 values that it can take. And what's going on is that we don't want this to be a float, we actually want this to be a Boolean, because then we can again do, it's an appropriate data type for the column, and we can do more complicated things further along. So let's run this guy, and now let's run flights diverted, and now you notice that it's all Boolean values, either false or true, which makes more sense for this particular column. So this is actually where I'm going to stop the video right here. We still have some more data cleaning stuff to do that we'll discuss, but just to do a quick recap, in this video we learned how to convert columns into their appropriate data types. And the reason that we do this is so that we can work with them a bit easier in the future when we're doing any kind of data analysis. So one thing in particular that we learned is how to convert a flight or a date, into an actual date-time object rather than it just being a string. And then we also learned how to convert these two columns into Boolean values by doing as_type np.bool. And this also works for other types as well. It doesn't have to be just a Boolean type. You can say convert a column to a floating point, convert like an integer to a floating point column just by doing the same sort of syntax, dot as_type np.float, for example, or float32 or float64 or something. So this is applicable to other things as well, but we've used it to convert columns to their appropriate data types. Now, this isn't the only kind of data cleaning task that you might have to do, but I'm going to stop the video right here, and then we're going to continue on very soon.